Thanks for listening. This is Brian Hurley from Business Performance Improvement. The podcast Lean Six Sigma Bursts are short lessons, comments, Q&A, and insights. If you have a question, send your question through the Anchor app, and we might feature you on a future episode. Or contact me at biz-pi.com. I was working with a client recently, and the discussion came up around a bottleneck in their process. When we identify a bottleneck, that's usually where we can't go any faster and we can't produce any more than what that process can handle. And so the whole pace of the production is limited by that bottleneck. And so when I hear about bottlenecks, I think about the concepts around theory of constraints, which is a 5-step process for breaking down and alleviating a bottleneck in the process. The 5 steps are, first of all, you have to identify the constraint and figure out where it's at and what problem it's causing and understand how it is limiting the flow. Then we go to the 4th step of elevate the performance of the constraint. And so now we might look at some larger improvements. Maybe we throw more resources at it and people to help alleviate that constraint. Maybe we invest in upgrading equipment or automate certain parts of the process. And eventually, if we make enough improvements there, we might move the constraint and the bottleneck to some other part of the process. And then we go through this process again where we repeat and go back and find out where is the new bottleneck or constraint in the process. So I just want to share an example of some of the things that we were looking at during this discussion around this particular bottleneck. So one of the things I asked about it was the downtime or the PM work that is being done on that equipment. So if that equipment is a bottleneck and it breaks down and it's down for a certain extended time, unplanned maintenance, then we want to look at how can we improve on the maintenance so that it doesn't fail. And maybe we can go in there more frequently and do smaller upgrades so that we can prevent the big downtime situations from occurring and breakdowns. So looking at the maintenance activity to make sure that that particular process or equipment is fully running and has all the right performance applied to it. Another thing we looked at was, since this process was running on a conveyor system, there was discussion that maybe the conveyor was getting hung up or wasn't flowing adequately through the process. And they thought that maybe there was an opportunity if they could alleviate a short delay in one of the steps where the sensors were misaligned and it was actually causing a couple second delay in the process. So if they were able to cut out that delay, they potentially could be increasing the amount of production that goes through there just by simply cutting out some waste of waiting or delays in the process. Another thing I asked about was, what is the rework activity that is going on in that bottleneck? So how much or what percentage of the units being run through that process are there a second time or third time versus this is the very first time that it's showing up there? In a perfect world, we want to have excellent quality going through that process so we don't have to have problems later on. And so every time that process is running a unit for the second or third time, that's a waste of that valuable constraint. And that means we can't be running new equipment through there, new parts through there, because it's working on old ones. So we want to do as much as we can to improve the quality of that process and the quality downstream so that it never has to come back through that process. Because in this process, they could have some things that get induced later, which would require it to go back through this process again. So we want to remove as much of that out of the process. Another piece is to look at the amount of mistakes and errors that are coming into the process for the first time. So a recommendation is to do additional inspection and review of all the parts going into that bottleneck and make sure that they are actually high quality. If we know we can see any kind of defects there, let's take it out of the process to begin with. Let's not run it through and then find out later it's got to come back through a second or third time. So part of the improvements to quality is to fix the issues that happen in the bottleneck and afterwards, but another one is to avoid having defective stuff go into the bottleneck from the prior process. So both of those we want to look at so that we can cut out any rework and waste as early as possible. And then the final thing that we talked about was checking and making sure that you are not running out of material going into the bottleneck. we don't want to starve the constraint, where the constraint is ready to run and there's no material there. And so we have to do everything possible to make sure that there is a buffer and a sufficient buffer in front of the bottleneck so that we never are running out of material. Because that's an opportunity where you are now ready to run the bottleneck and it's limiting your total output and you don't have the supplies there to run it. So we want to make sure that the prior process has got a lot of its issues worked out so that it is consistently flowing material to that bottleneck. And maybe even have a buffer staged so that you can handle any downtime or issues from that prior process so that it does not affect that constraint. So I hope this discussion around the theory of constraints and looking at bottlenecks was helpful. But even for a process where I think the team felt like they had done as much as they could, I think we had some really good discussions around how we could even look for these other opportunities in the process and try and cut that down as much as possible so we can get as much as we can out of that bottleneck, but without having to throw more money at it. So I hope that was helpful. Let me know if you have any questions. Thanks. Lean6sigmadefinition.com has a list of glossary items about popular process improvement terms, along with the history of Lean and Six Sigma methods, and key influencers like Dr. Edward Stemming, Henry Ford, Taiichi Ono, Shigeo Shingo, and many more. You can also learn how to access affordable Lean and Six Sigma training and certification. Visit Lean6sigmadefinition.com.